Starting with our series circuit, in the daytime the LED should be powered on, and in the nighttime the LED should remain off. Here we can see that in the daytime our current will go through our 330 ohm resistor into our LDR, powering our LED. In the nighttime our current goes through our resistor, but not past our LDR, not powering the LED. The circuit on the breadboard shows our 330 ohm resistor connected to the top, and in the same line connected to our LED, first through our anode, which is the positive, and then through our cathode negative, which connects to our photoresistor, which connects to our ground. Here we can see our photoresistor is exposed to light and the light is on. When we cover it, the light turns off. Next, we have our parallel circuit, which is the opposite of our series circuit. In the daytime, the LED will remain off, but in the nighttime, the LED will turn on. Here we can see in the daytime, our current will go through our 330 ohm resistor into our LDR, with little current going into the LED, so it won't be powered on. Next, we have our current in the nighttime going through our resistor into the LED, powering it on, with little current going into the LDR. Here's our circuit, and we can see our 330 ohm resistor connected to the top, and in the same line is connected to both our photoresistor and our LED. Our LED is connected to the anode first, and the cathode is connected to ground along with the photoresistor. This creates a parallel. As demonstrated here, we have our circuit connected. I connected another light to put up to the light sensor, and when we put it up against it, the LED connected to the circuit will turn off. When we take it away, the LED turns back on again. Next, we have our transistor, and it works the same as our parallel, where in the daytime the LED will remain off, and in the nighttime the LED will remain on. Here we see our current in the daytime going towards the first node, with little current going into the first resistor, which is 330 ohms, but most current going into the 100K resistor, splitting off into the other node, little current going to the NPN, and most of the current going to the LDR. This will not power up the LED. In the night, we see our current going from the first node, and most of the current is going towards our 330 resistor, powering the LED into our NPN. From the first node, we see most of the current also going to the 100K resistor into the NPN again. And with the second node, we see just a small amount of current into the LDR. First, we see our 330 ohm resistor and 100K ohm resistor connected to the top. Our 330 is connected to the LED, and the LED is connected to the NPN transmitter via jumper, and our 100K is also connected to the NPN via jumper. Our 100K is also connected to the photoresistor, which is connected to ground, and through jumper to the NPN again. Here we have our circuit, and if we put an LED light up until the sensor, the light will dim, and when we take it away, the light will turn back on again. Lastly, we have our microcontroller, which uses Arduino code to sense the ambient light in the room using the photoresistor to turn on and off the LED according to a threshold that we assign. We can see our 5 kilo ohms resistor up on top, which is connected via jumper to our 5 volts on our Arduino. Then we have it in series with a jumper cable connected to analog, in series with the photoresistor, which is connected to ground, which is connected to our ground via jumper on our Arduino. Then we have our 330 ohm resistor connected via jumper to our 8-pin, and it is in series with our LED from anode to cathode, which is connected to ground, which is in parallel with our photoresistor and connected to ground as well via jumper. And finally, we have our sensor threshold, which is Due to 950, our sensor is picking up around the 800s, which means our light is on. But if we cover that sensor, the light would turn off, which means it's above our threshold. And if we look, it is above 950.